Hello guys and welcome back to the channel. Today we're gonna start explaining our node tree, our sofa node tree, or our furniture node tree right here. And I've already talked about this node tree and about this object. So if you want to see the introductory video to it, I don't know, watch it somewhere here up. I don't know where I'm gonna put it, or in the description it's going to be linked to the first video of the series. We actually didn't do nothing but show a little, explain a bit about what this is. So this is actually the first tutorial video, and as you can see, this is the node tree that comes out looking like this, and we're gonna explain it node per node. And let's start just with one inevitable tip, and that's install your node Wrangler. Without it, I don't know what can you do. It's just impossible to work with nodes without it. So add-ons, search for node Wrangler, and then enable it. It's really indispensable. Okay, so once you have it, and we're going to use its shortcut, and especially the one we're going to use the most is Shift Alt left click. So Shift Alt left click lets you connect the node is selected to the geometry output. So geometry output, so everything goes into geometry output, and it comes out looking like this. If I was to, for example, select this last node here, Shift Alt click, and this is what comes out of this node. Out of this node, this is what comes out of it. Out of this node, this is what comes out of it, and so on. And I've actually constructed this node tree like this. So in these these are my legs, then it's gonna be my base, and then it's gonna be my back, and so on and so on. So let's start with the first thing, our legs. So the first thing, Shift Alt click, this is what I started with. So this node is called the cylinder node. So to add nodes, you just press Shift A, and then you can add them like this manually, or you can press Shift A S to go into search, or you can even press your space bar to go into search directly. And if you search for cylinder, for example, cylinder, and here it is, add mesh primitives cylinder, and it's gonna add this exact node that I'm having here. Okay, so now I set my radius. You can set your radius here. You can set your fill segments. What's this? Fill segments. Sorry. Let's just turn on the wireframe for just a second so you can see better what's going on. Okay, so wireframe, fill segments up here. We don't need all those segments, we just need one. And slide segments are the loop cuts here if you want them. I didn't want that. And vertices, you can have more of it. Okay, so let's leave it like this. And then what I did, let's go into this node, Shift Alt click. I actually moved it on the Z-axis. How I did this? This is a transform node, so Shift A S, transform, and here it is, looking just like this. I'm not gonna add them every time, so I didn't change the names of these. You can change the name of these and then it would look different, but I actually didn't do this just for the sake of knowing what a certain node really is. So I left it as a default, so you know what node are we talking about, and you can always find it easily and change it and understand what's going on. Anyway, so this transform node changes the position, the rotation, and the scale of this object. Like this. Very simple. But we don't want to change nor the rotation nor the scale. We just want to change the translation, and we want to move it on the z-axis up here to have its base exactly on the 0, 0 plane, so on the floor, let's call it. And how we're going to do that, since sorry, one thing I forgot to say, the most important thing maybe, is this cylinder has also the depth, and that's the size on the z-axis. See, it's changing, and this size we want to control it, and we want to control it with this parameter right here. No, here, where it is, height, legs. Okay, this parameter. And we have our group input node. Let's just open it so we see. So all these, so group input node, you will have it when you add a new geometry tree node. You will have your group input and your group output I showed you before. And the cool thing about this group input is that you can add stuff that's going to show right here in the geometry nodes side panel, modifier side panel, and you do it just like this. You just connect with a value to the geometry input node like this, and here it shows value. We're going to undo this because we don't want another one. Okay, or another way is just by expanding the side panel here that you could do with the shortcut N like this, and pressing N on the keyboard, and just add it normally like with a plus sign, just plus, and it's going to add another one, and then you can change its name. You can set the default value, you can set the minimum, the maximum value, and you can set the type. So the type, you can set even an image now. This is the last improvement. Object, color, format, float. Float is a number, a decimal number. You can set the texture, collection, and integer. Integer is a non-decimal number. So 1, 2, 3, 4, 5, that's an integer. A Boolean, so true or false, and so on. But we don't need this side thickness. Let's just remove it so we don't make a mess. Okay. And this is how we control the shape of our object made with nodes. So we just connect little sockets and make them work. And so the depth right here is actually the leg height. So we want it to be controlled with the leg height like this. Okay, so the leg height is set to 0001. So if we increase it, you see that it changes, and that's what we wanted. And since you can use this group input however many times you want, so if I was to duplicate it with Shift D and move it somewhere else, I could still use this and connect it to other stuff, and it will still work. And fortunately, this is enabled because if I had to like connect every single node that I have kilometers away from this original group input, it would be so much, it cause a grave mess, and it would be impossible to understand what's going on. So thankfully we can duplicate it and then connect it to other stuff. But and another cool thing and another cool tip is the Control H shortcut. It hides every single socket that is not connected. So if I was to press Control H, every single parameter here is being hidden because we actually are not connecting from this node anything else but the height legs parameter. And to bring it back again, Control H, Control H. That's very simple. Okay, so now we want to translate it on the z-axis. How much? Well, it's simple. The height divided by 2. That's actually like this. This is the height divided by 2, and we're going to move it just as much. We can move it. Why do we need? So we can move it like this. Just how much is the height? Okay, 1.1. So a half of it is 0.055, right? And perfect. It works nice. But when we increase the height, it's not working. So what do we need to do? We need to actually connect it to another node. So combine XYZ node. This is just one socket, and we need to separate it to 3. So X, Y, and Z. So we connected this one, and now we control it with this one, only the Z value, right? Perfect. And then we need to, the X and Y can stay at 0 because we don't want to move it in this direction or that direction over there, but just on the Z-axis. And how much we want to move it? We want to move it the height divided by 2. So this is a math node, and it's the only node that doesn't say math, even though it's math, but it says the operation that you change here. So these are the operation of the math node, and this is maybe the most used node in every geometry tree by far, because everything is math. So you added Shift A S math, and here it is. See, now it's called add because we'll call it square root. It's going to be called square root, but you'll get the hang of it. So so we wanted to divide by 2 this height legs parameter, and we'll get the size of the Z value that we want to move it. Perfect. So now we moved it exactly the half of the value of height legs. So if we change it here, it still moves it and stays there where it needs to stay. Okay, let's go. Now it gets a bit more complicated. So let's start with another node. This node is called set position. And now here we're entering the fields area of geometry nodes that we didn't have until Blender 3.0. And everything you knew about attributes, just delete them. Delete everything you knew, and let's start all over. So set position is a node that helps you set a position of your geometry. So if I was to disconnect all these, and I will connect this one because otherwise I don't know what we're doing. So position is we are changing the position of all these vertices right here. Let's just see what's going on from this node on. And so we have our position, and the position, as you know, is a vector, because when you move stuff, you move it in 3 directions, these 3 directions. So we need the combine XYZ node so that we can separate our XYZ position. And if I was to disconnect this one, as you can see, what happens here now. So I'm telling to all these vertices, these are all coordinates of all these vertices, because we had like 16 vertices per base, so it's 32. First one is ID'd 0, so it's 32 vertices. And I'm telling, since I plug them into this geometry socket here, I'm telling with this node to set the X position of all these vertices. As you can see, the X position is right here, to 0. And if I was to change this value, it would change here. But that's not what we want, obviously. What I wanted was to increase this. Let's scale this circular shape here so that I can have like a torus. So what do I do? And this, here comes our first field. So this field position. Let's go into add node and go into our input. So all of these right here are the fields that help us work in these new geometry nodes. And what does this do? These nodes are not some fixed, do not have some fixed value, but are actually telling us, or telling Blender, to watch this position from the geometry node that they refer to. So this position is this position node is going into this node. So here, this position for the vertex number 19 has this value, but in this node, for example, again, this number 19 vertex is going to have a different position field. This is a bit confusing, but you'll get the hang of it the more you do with it. So here, even though I can duplicate this and put it here and do something with it, here this position will have one value, and here is going to have a different value. So it kind of works. It kind of works backwards, kinda. But anyway, so in this position node, there is all this information about the position of all these vertices. And so what I'm doing with this, I'm saying, okay, this position, I can obviously, I need to separate the XYZ because this is the position has 3 values, X, Y, and Z. So I need to separate it. It's a vector, so into 3s. And then if I was to mute these two with M, nothing would change because X stays the X, Y stays the Y, Z stays the Z, and nothing changes, obviously. But if I was to do something with it, and then a lot of things change. So what did actually change? What did I say? I said I want X to add, this is a math node, to add another X. So this position 004, sorry, 00001, for example, this vertex is 0, I'm adding this one to, so our, and then I'm bringing back the result into the X. So this X has become double of this X. So if I mute it again, for example, so this X value here, so if this is our X and Y, so this value here on X and Y, it's getting doubled. So what we're gonna have, like a bigger circle, and this happens and this happens for all vertices, but I just want these upper ones, and I'm gonna tell you in a second how we're gonna do that. But first I want to show you a different way to do the same thing, but have a bit more of control. I didn't need the control for this example, but if you would want some more control, how would you do it? So I'm actually adding two identical values. So it would be the same if I was to multiply this with the value of 2. For example, multiply, just connect this one with the value 2. And sorry, I typed the wrong number, so value 2, and it works the same. And then I could add a value node and plug it in here. And then I could have more control on the size of the radius, right? Let's keep it at 2 for now, because that's what we had before. And then, and you can obviously you could have plugged this into somewhere here and then control it from the modifier panel, side panel right here. But we don't need that for the moment. Okay, but let's go back to our leg. So I want to scale only this part. So how can I do that? We have a selection socket here. So how can we select only these vertices? Remember the attributes when we had like attributes here in the spreadsheet? So we would add an attribute and then it would appear and it would have a value for each vertex. It's similar, but unfortunately we cannot see what's happening. So what do? We use the same position node. Don't get confused if... Okay, let's do it like this. It's the same thing, but maybe this, for the beginner, it's easier to understand. So we're using the same position values, and we're just taking the Z, and we want to select only the vertices that have the Z value bigger than 0. So we don't want these here. We want the ones up here. So we will use the math node again, but with the operation greater than. So greater than, so Z, plug it in here, and greater than 0. So all these vertices here, all these ones from vertex number 17 to the vertex number 31 will have the Z value of 0. And so this socket here will push forward the true or false, because that's the only thing that can come out of this operation greater than. Imagine it like it was an attribute here, and it said true or false. So here would be written true, and here it would go false. And then when you connect it to the selection here, this node tells Blender to change the position, this position here that we set here, only to the vertices with this attribute, but actually it's a field, set to true. So it's changing only the first 16 vertices, and it's leaving the other ones that don't have the Z bigger than the threshold to where they were. And that's what's happening. So these one stay the same and these one get bigger. See? Sorry, we disconnected this one. Okay. Let's put it back to 2. Okay, let's move on. Oh, this is gonna take so much time to explain everything. Anyway, I'm hoping you are kind of getting a bit of cool tips. Let's see what goes on in this node. We're gonna go a bit faster now, don't you worry about it, because some things will repeat. So this is the similar thing. So what I wanted to do here, I wanted to move it a bit in this size, on this side and on this side. I wanted to make it like going there. So what do I do? Again, set position value. So now this position here has a different values or different fields than these positions too, because we've changed them with this node here. Okay, but still, how do we do that? I wanted to change only these vertices, and I wanted to move them in this direction a number and on this direction a number. And how I'm going to do that? Again, selection, pretty simple, is the same thing. So position greater than 0. So like we want only these vertices. And how do we move them? Very simple. Again, position combine XYZ here and position separate XYZ. And we just need to add a number to the value. So X gets added this number and goes back into X. Y gets added this number again and goes back into Y. And what number did we add? Okay, let's just talk about this a bit. So if I was to add a simple number like this, nothing happens. Sorry, what happened? Because we are not in this node. So this is the output. Okay. So see that I'm moving it now. As I'm changing this value here, this is just multiplied by 1. So it's practically like a value. And it's moving. Okay, so if I was to, I don't know, set like a value of 0.06, for example, if for me this is a good shape, what happens when I change the height of the legs? See that it changes the angle. So if the height of the legs, if you want it really, really low, like this number, then it really gets distorted and no furniture is going to be looking like this or made like this. So what do we need to do? So we need to parent it to the height of the legs. So that's why I used this group input again, and I plugged in here, and then I wanted to see what would happen, and I kind of looked for the perfect angle, and for me the perfect angle was somewhere around here. And now, as you can see, the height legs moves, but the angle, or at least the angle of the line connected the center of the two circles, remains the same, as you can see. And that's what we were going for, right? And that's it. Okay, with this one we done really fast. So next, transform node. We've already talked about one right here. What happens with this one? I just wanted to move it on the X and on the Y just a bit. Y, we're gonna see it later, but anyway, and it's just a fixed value. So on the X, 5 centimeters, and on the Y, 5 centimeters. If I was to mute this node, so this is what happened. Perfect. Now let's go on. This node, another transform node. Here, I wanted to translate it into position. So remember, we were going to have something that's going to have a width and a height. So if we had a couch, this would be our couch, since everything is made from the center. If we had a chair, this would be our chair. And these legs are gonna go somewhere around here, no? Somewhere around here, not at the very tip or corner, but somewhere around here. So we need to set the position, and that's why I moved it here just 5 centimeters. I moved it 5 centimeters from the edges. That was the point. And you've guessed it, how much do we want to move it? We want to move it this size. And how much is this? It's difficult to understand now, but let's imagine our sofa like this being the width and this being the depth. And how much? So we need to move it. We need to move it exactly half width on the X and half width on the Y. And that's exactly what we did. So translation, vector, X and Y, depth divided by 2 and width divided by 2. Okay, I moved it in the different direction. So I moved it on the negative Y and on the negative X, but it's the same thing. It doesn't change a thing. We can even do it if you want, like 2 positive and 2 positive. Here goes, it's here now. Okay, and then another transform node. No, this is the one. And then our join geometry node. So join geometry nodes joins 2 geometries. So if I another thing about nodes. So every node, everything coming from this side can have only one connection. So I can connect this into here, but if I was to connect this one again into here, it would not allow me and it would break the previous one. So everything that comes from this part is unique, but everything that comes out can go as many times as you like. So as you can see here, so what I did here, I actually copied a geometry with this setup, because I said, okay, let's take our leg and let's push it into a join geometry. And then let's take the same leg and push it into our transform node and transform it. And I did that. And then I transformed the other one, the copy, and put it back into a join geometry. So I actually created a copy this way. And what I did, so I created a copy and then I scale it on the x-axis. And see, it's like I'm mirroring a copy. So this is a copy and I just scale it -1 on the x-axis, so I practically mirrored it, and that's how I created a second leg. And then I did the same exact thing for both of these legs. So this join geometry, so here we have our 2 legs, and then I created a copy going once, going twice, and I scaled it, the copy, on the y-axis and created the copy on this side, as you can see, like this, -1. And now we have our legs that move according to these 3 parameters. So depth, let's go a bit closer so you can see. So depth, width, and height of the legs. Oh, I see now we have the wrong angle here, but that's because of our -2. So we need to bring back the -2 here and go on the Okay, perfect. Next, what we have is our set material node. This is very simple. So set material nodes just allows you to select, to add a material. We have a socket for material legs in the group input. It's right here down there, material legs. We're just going to connect it to this. You also have the selection socket if you need it, but we actually want the whole of geometry to have the same material, so we don't need to select anything out of it. Just everything will be selected and everything will be applied with the material that you're going to choose from the list of the materials you have in your scene. And then the shade smooth. Okay, the shade smooth, let's just turn off the wireframe for a second. Wireframe for a second to show you that we are actually shading smooth only a part of these. This would be something like an auto smooth, but we don't have the auto smooth node. We just have the shade smooth or don't shade smooth, but we have this selection socket. So how do we shade smooth stuff, that only the stuff that we want? And it's simple. So we need to shade smooth only these parts and only these. We don't want to shade smooth this and this. So how do we do that? Into our selection, go into our position, then again vector z, and what values. So z value, the z value of these points is 0. We see it here. But the z value of these points changes according to the height, as you can see. So this is the points that are here, 0.16. If we were to change the leg's height, these values would change. So that's how we are gonna know what they are. And we're gonna use our compare node. Okay, let's try to draw it. So if we have a line like this and all the points are on this line, and for example I want to compare something with this value, and now this epsilon value is the size on how much can we alter the comparison. So for example, if the epsilon value is this here, then all these values here will come out as true. If the epsilon value is, for example, this long, then all these values in here will come true comparing to this size. If we're comparing to this, then we will need to these two values. Get it? I hope you do. Anyway, when it's 0, it just needs to be the same exact value when it's 0. So this value, only this one compared will come out as true. So when it's 0, and in this case is 0, we need to compare it to the value of the height here and the value of the 0. So when it comes out as true, then we will shade smooth it. We will smooth shade it, smooth shade it. And here we have another node, and this one is Boolean math node. So a Boolean math node is very simple. It comes in with two possible values, true or false. So this is true, this is false, and you can also always put a socket in it, put a socket in it, and then this is the operation. So and So if this is true and this is true, then comes, sorry, if this is whatever it needs to be, it will come out as true. And if only one of them is true, then it will come out false. If both of them are false, it would come out false. And then we have or. So if this is true and this is false, it will come out true, because either one of them needs to be true to come out to have a result of true. And then we have the not. So if this one is true, then here we will, it's just like an inverse. So this is true, this one will come out false, and if this is false, this one will come out true. Okay. So we have our, so we need to not select these vertices. We don't want to select these vertices. We want what's in the middle. So because here we go out with true, this one comes out true, and we have our not math Boolean operation. So here comes false, so we don't want to select these. And then we want to select both of not these, and then the selection will come out looking like this. And here we need to select if we want to shade smooth or not. So here we are actually shading the cylinder part and not the edge right here. This one is a bit complicated, but I hope you guessed it. Anyway, these are our legs. Imagine how much time we spent just talking about these legs, and we need to talk all these things to all these things. And anyway, this is it for this video, because it took me much more time than I hoped for. But the next one is going to be faster and faster, because I will practically use a lot of techniques and nodes that I already explained to you in this one. So thank you for watching, and I'll see you in the next one. Bye bye.